Okay, this is a continuation of the other video which got cut off. I believe the computer overheated and the program shut down, but anyway, I got to finish this one and do one more. So this again gets divided into every term on the top in the numerator. In this case, there's just two terms. Okay, some kids find this tricky. There's a term, there's a term. This 2 must get divided into both of those because those are separated by this plus minus operator here. Okay, so if you want to write it out like this, you can, feel free. I suggest that, I recommend that, and we start practicing this back in grade 9. So we've got negative 2 over 2 plus or minus. This 2 can now cancel with that 2. Okay, and if you're really good, if you're sure you're not going to make a mistake, sure, you can just jump to that in one step. This 2 goes in here, this 2 goes in there. Okay, but again, if you think you might make a mistake, take the extra 5 seconds, write it out. So there is 2 answers there, right? Plus or minus. This, one of the roots is negative 1 plus root 2, and the other one is negative 1 minus root 2. Okay, 2 separate roots. And if I pulled out either my Desmos graphing program or my graphing calculator, I could put those in, get these, and show you that that's where the x-intercepts are. That's where the roots are. If the question, let's look at it, it does say exact value, so I'm done. And just for further understanding, they want this answer to the 10th too. So let's see what this actually looks like as a decimal. Negative 1 plus root 2. Okay, there's one of the roots, 0.41. Of course, you can't factor that. That would be impossible. Or next to impossible. And negative 1 minus root 2 is negative 2.41. Ooh, I don't remember. Was that to the hundredths or the tenths they wanted it? To the tenths. So get rid of that, get rid of that, okay? Same answer, but now it's not exact. It's a decimal approximation of what this is. So read the question, whatever you get, and answer it appropriately. Okay, there's your 2 roots of that quadratic formula. Next one. Does that look like that? No, it doesn't. It must be in this form, otherwise you can't use this. So my first step is to put it in that form. I want to see what A is, I want to see what B is, I want to see what C is, so I can substitute them in this formula and solve for the roots, okay? So don't try to do this in your head, you're going to make a mistake. I need to make it look like that, so my first step is get rid of those brackets. Remember all of these you did back in grade 9? That's the reason. So now you can do it in grade 11. 3 times 5 is 15. Distributive property, right? Still doesn't look like this. I want to take everything, put it to one side, having 0 on the other side. And then there's always a question of, do I want A to be positive? Do I want it to be negative? Because if I take this and put it over here, it will be minus 4x squared plus 12x plus 15. It's not wrong, but then you're asking, does the parabola look like this, right? Or does the parabola look like that? It doesn't matter in either case because you're going to get the same roots, but personally I like to keep A positive, so I'm going to keep that there, and I'm going to take these and throw them over to the left side, okay? So in other words, minus 12x to both sides. It's gone on the right, it's over on the left. Okay, minus 15 to both sides, or take that 15, chuck it to the other side, change the sign. Okay, so minus 15, that's gone. Minus 12x, that's gone. What do you got left on the right-hand side? Nothing. So write nothing, equals 0. Now you see what A is, write it down. Now you see what B is, write it down. C, write it down. Okay, don't forget the signs. Now I can plug it in this guy. So minus B minus B, use brackets when you substitute, or you're going to make a mistake, right? So that becomes positive 12, right? Plus or minus B squared. It is not minus 12 squared. It is bracket minus 12 squared. Big difference. Minus 4A times C. Okay? All over 2 times A. Okay, there's the hard part. Putting it in properly. And, of course, if this is a 2-mark question, you already got half a mark, maybe 1 mark, right? The rest is just, hopefully we don't make a mistake working this thing down. So positive 12 plus or minus, what's under the radical sign? Pull out your calculator. Well, I forgot a bracket there. If you want, okay, but that's 144. A negative times a negative is a positive. Now you don't have to look at the signs. What is 16 times 15? Or 4 times 4 times 15? I'm going to use my calculator. 240. 8. 2 times 4. Okay. Now right away, if you made a mistake here and you forgot one of those negatives, if this was a negative here, would we have a problem? Can you take the square root of a negative? No, you cannot. You would have a problem. In that case, you'd get that. A quadratic. Sure, it's still a quadratic, but it doesn't have any roots, right? How many times does this thing cross the x-axis? It's still okay. You'll put that in your calculator, though, and it'll say error. Well, that's the reason why, because you can't take the square root of a negative yet. So 12 plus or minus. What's 240 and 144? 384. Is that a perfect square? It is not. So I got to work this thing down. Okay? It's not very pleasant, but remember all this stuff we gave you? 384, what's the largest perfect square in there? Remember this radical chapter we did quite a while ago? I have no idea. But I know it's even. I'm going to take a 2 out. What's half of that? I don't know, I should do this in my head, but I'm going to cheat. 192. Okay? Still don't know what goes in there, but it's still even. Let's take a 2 out of there. 96, right? Let's just double check. It's early. Whoop. $96. What goes in there? 2 does. Okay. And that is 98. That doesn't make any sense. What am I doing? What's half of that? 48. Okay, and that is 6 times 8, is it not? Okay. So, where's a perfect square? There's one, 4. Here's another one, 4. So I've got 16 times, here's another one, 4. Scratch that. I got 64 times 6. The only one left is the 6 here, right? Double check. 384 is 64 times 6. There are no more perfect squares in 6. So that is the largest perfect square, okay? So if I go root 384, that's root 64 times 6. That's root 64 times root 6. And of course that is what I want. 8 times 8 is 64. So that is 8 root 6. Pray you don't get one like that on your quiz or your test. Okay, so there's my two roots. Again, I'm answering this question, exact values. Otherwise, I would have just put this in the calculator a long time ago if all I wanted was a decimal, okay? What goes into 12, 8, and 8? Is there a number like 4? Goes in there 3 times, goes in there twice, goes in there twice, okay? And that's as nice as it can get. So I've got 3 plus 2 root 6 over 2. That's one of the roots. And I've got 3 minus 2 root 6 over 2 as the other root. Those are my two roots. And to make more sense of it, as a decimal, come on, 3 plus 2 root 6, just one of them. Okay, either bracket or all that or hit enter, then divide by 2. 3 point, and they want tenths, don't they? Ooh, there's a debate here. Does that 9 make the 4 a 5, which makes the 9 a 0? Is that 4.0? Or do I just look at the 4 and go 3.9? I've seen it both ways, guys. Okay, it just kind of depends what textbook you kind of got trained with. So I'm not getting into a debate there. If you put either, I'll mark it right. Okay. I gotta research my significant figures here to get an exact answer off the top of my head. Like I say, I've seen it both ways. And minus 0.9, let's call that. Okay, there's the two roots. X-intercepts. Zeros, whatever you want to call them. Okay, tough question. But, like I said, quadratic formula, that's the way you're going to solve these guys. Okay, there's your questions. And that is it. No. That's what I want.